To implement authentication and authorization, the first thing we need to implement is registering the user. So currently we have this registration form, but nothing happens when we click the register button. Now, before we start coding, let me give you a quick overview of the changes we need to make here to implement registering the users. So let's go back to Postman. We have this endpoint /API/users. If we send an HTTP post request to this endpoint, we can create a new user. Here in the body of the request, we should pass all the information about the user as a JSON object. So here we select raw and then JSON. Now we can add a JSON object with 3 key value pairs. The first one is email, which we set to a valid email like user1@domain.com. The second is password, which we set to 123456. And the third one is name. So these are the properties that this endpoint expects to receive. This is purely my implementation. In your applications, your backend might expect other properties. Now, let's go ahead and send this request to the server. So we get a response with the status 200, which means successful. And here in the body of the response, you can see our user object. Here we have this ID property that uniquely identifies this user. We also have name and email properties. And as you can see, password is not here for security reasons. Now, let's see what happens if we send this request one more time. This time we get a 400 response, which means bad request. And here in the body, you can see the error message, user already registered. So in your applications, whether you are going to build the backend yourself or someone else is going to build it for you, this is how your backend should behave. You should have an endpoint for registering users. So that endpoint should receive an HTTP post request and it should respond with either 200 or 400. So now you have an understanding of how the client and the server are going to communicate to register a new user. Next, we're going to modify our registration form to send an HTTP request to the backend. Currently, we have 2 services for working with our API endpoints, genre service and movie service. We're going to take the same approach, create a new service, call it user service, and make it responsible for talking to our user's endpoint. So anytime we want to register a user or delete a user or get information about the user, we're going to use that service. So here in the services folder, let's add a new file, user service.js. Now to speed things up, I'm going to copy some code from our movie service. So on the top, we should bring these 2 import statements as well as this constant API endpoint. So copy, paste them here, and then change API endpoint to /users. Now we should export a function, call it register, which takes a user object. And in this function, we should call http.post. We pass our API endpoint, and this is the object that we should include in the body of the request. This object, as you saw in the last lecture, should have 3 properties. Email, which we set to user.username. The reason I didn't set this to user.email is because in our registration form, we call this property username. Let me show you. So let's go to register form component. On the top, here's our state object. Look, this object, our data object, has 3 properties, username, password, and name. This is a common scenario in real-world applications. Sometimes the front end and back end are built by different people, so the namings don't always match. Or it's even possible that you build both the front end and back end, but you're not consistent with your naming. Now, in this case, this is a tiny issue, but if you can make the names consistent, your code will be always cleaner and easier to maintain. Now, back to our user service, we should also send the password. So user.password, and finally name, which we set to user.name. So we send this HTTP request to the server and then return the promise. That's it. Now let's go back to our register form again. So register form. On the top, we should import our new service. So we can import one function like register from, we go one level up, and then in the services folder, we load the user service module. So that's one way. Or we can import all functions in this module using this syntax, star as user service. With this syntax, we'll have a user service object in this module, and the functions we have exported from user service will be methods of this object. So with this, we can go to our doSubmit method and call user service dot, look, this is our register method. Now you don't necessarily have to import all the functions in the user service module. Maybe all you need is the register function. So you could simply import that function. But I just wanted to show you a different syntax to work with these modules. So we call user service.register and pass this .state .data. So this returns a promise. We need to await it and mark this as async. Let's test the application. So back in the browser, I'm going to supply a different email. So user2@domain.com with this password and my name, register. So currently we don't get any notification on this page. But if you look at Chrome DevTools under Network tab, you can see we have a request to our user's endpoint. And this is the body of the response. So we successfully created this user. And you can also verify this by looking at the users collection in our MongoDB database. So currently we have 2 user objects. Beautiful. Next, we'll look at handling the scenario where the username or email already exists. In the last section, you learned that in order to handle server errors, we should wrap this line in a try-catch block. So let's add a try block. Move this line here. We add the catch block. Here we get an exception. We need to check if this exception or error object has a response and x.response.status is 400. That means we as the client did something wrong. So we should display one or more errors on this form. Now in this case, the only kind of error we get is user already registered. So just like before, we should clone our errors object. So we set this to a new object and spread this .state.errors. Now we set errors.username to, we can pass an error message here, or we can use the error message that we get from the server. That is available via x.response.data. So finally, we call this .setState, and we pass our new errors object. Let's test the application. So one more time, I'm going to create this user. And we got our error message here. Beautiful. So our registration form is working. Now, technically, in a real-world scenario, at this point, we want to automatically log in the user and then redirect them to the home page. But let's temporarily park this part and focus on our login form. When we build the login feature completely, then we'll come back to our registration form and log in the user automatically. So next, we'll look at this login form. Previously, we looked at the user's endpoint for creating a new user. We have a similar endpoint, that is auth, for managing our authentication sessions. So in order to log in a user, we should send a post request to this endpoint. And in the body of the request, we should have a JSON object with 2 properties, email and password. If we send a valid email and password combination, the server will give us what we call a JSON web token. Let me show you. So send, look at the body of the response. You have this long string. This is a JSON web token. You can think of this as an identification card, like a driver's license or a passport. So if the client sends a valid username and password to the server will give the client an identification card. Now in the future, whenever the client needs to call API endpoints that need the user to be authenticated, the client will send this JSON web token back to the server. The server will then validate this If it's a valid JSON Web Token or a valid identification card, then it will execute the client's request. So this is the big picture. Now, throughout this section, you're going to learn more about these JSON Web Tokens. For now, just think of them as an identification card, like a driver's license. So next, we're going to modify our login form and send an HTTP request to our auth endpoint. Once again, in our services folder, we should add a new service called auth service. And this service will be responsible for operations like login and logout. So to speed things up, I'm going to go to movie service. On the top, I'm going to copy these 3 lines, paste them here, and then change the API endpoint to /auth. Now we need to export a function called login, which takes a username and a password, or more accurately, an email. And in this function, we should call http.post, pass our API endpoint, and in the body, we'll pass an object with these 2 properties, email and password. And finally, we should return this promise from this function. That's all we had to do. Now let's go to our login form. So login form. On the top, we should import our new service. So import, we can import just one function, that is login from, we go 1 level up, /services/auth service. Now let's go to our do submit method. Here we're going to call the login function and pass this .state, .data, .username, or we can use object destructuring. So let's grab data from this .state and then pass data.username as well as data.password to our login function. So this returns a promise. We should await it and also mark this function as async. Let's test the application up to this point. So here in our login form, I'm going to pass a valid username and password. And then if you look at the network tab, you can see we have a request to our auth endpoint. And in the body of the response, you can see our JSON Web Token. Beautiful. Next, we'll look at handling the login errors. If the user sends an invalid username and password combination, we should display an error here. So back to our login form, we should wrap these 2 lines in a try-catch block. So here is a try-catch block. Did you see what I did? Let me show you one more time. So I typed try. Now look at this snippet. We press tab and we get a try-catch block. So that was a quick shortcut for you. Now let's move these 2 lines inside of the try block like this. In the catch block, we get an error or an exception. Previously, we called it X. So I'm going to use the same naming convention here. Now we need to check if X has a response and this response has a status of 400. If that's the case, we should display the error. So just like before, we'll clone our errors object. We set this to a new object and spread this .state.errors. And then we'll set errors.username to x.response.data. So with this, we'll display the error that we get from the server. And finally, we should call this .setState and pass our new errors object. That's it. Let's test the application. So I'm going to pass an invalid email and password combination. We get our error. Beautiful. So our login form is working. Now the next thing we need to implement is storing the JSON Web Token on the client and redirecting the user to the home page. And that's what we'll do next. So when the user successfully logs in, we get a JSON Web Token, which is like an identification card. At this point, we should store this JSON Web Token on the client. Where? Well, every browser has a small little database called local storage. And in this database, we can store key value pairs. So here, when we await the promise that we get from our login function, we get the response object. This response has a property called data, so we can use object destructuring to pick the data property, but because we already defined data earlier, we're going to rename this to JWT. So with this, we can get the JSON Web Token in the body of the response. Let's verify that. So console.log of JWT, save the changes, back in the browser. Here we have a valid username and password, login. Look, this is our JSON Web Token. Now we're ready to store this in the local storage. So we access the local storage object. This is available in all browsers. This object has a few useful methods like setItem, removeItem, and so on. Here we're going to call setItem. This method takes two parameters, key and value. And as you can see in the IntelliSense, both these parameters are strings. So I'm going to set the key to token and the value to JWT. Save the changes. Now one more time, let's log in with a valid username and password. Now open up Chrome Developer Tools. Now under the Application tab, here we have storage, we have local storage. Let's expand that. We have a local storage per domain. So this is the domain of our application, localhost, port, whatever. In this domain, we have this small database, which consists of a bunch of key value pairs. So here's our key token and the value is our JSON Web Token. Beautiful. Now, the last thing we need to do is to redirect the user to the home page. So earlier when we talked about routing and navigation, you learned that when we implement routing in our application, the props object we have here will have an additional property called history. And this represents the browser's history. So here we can call the push method to navigate the user to a different address. In that case, the home page. Now, let's test the application one more time. So let's submit the form and we're back to the home page. Beautiful. So our login form is functioning properly. Next, we're going to go back to our registration form. And when the user registers, we want to automatically log them in so they don't have to manually fill out the login form one more time. Once again, here in Postman, let's send a post request to our user's endpoint to register a new user. So here in the body of the request, I'm going to change this to a unique email that I haven't registered before. Send. Now look at the body of the response. Okay, beautiful. Look at this headers tab. These are the HTTP headers that are sent by our server. So here we have a custom header that is x-auth-token. So whenever a header starts with X, that is treated as a custom header that is not part of the standard HTTP protocol. As you can see, I've set this header to our JSON Web Token. With this, when we register a user, we can read this HTTP header, extract the JSON Web Token, store it in the local storage, and redirect the user. Now, in my implementation, I decided to use a custom HTTP header. You may prefer to return this JSON Web Token in the body of the response. So back here, let's look at the body. Just like we're returning the ID, name, and email, we could also return a JSON Web Token. The reason I decided to use an HTTP header goes back to my Node course because I wanted to teach you how to work with custom HTTP headers. Now, back to our register form. In the doSubmit function, when we call the register function, here we should get the response. So, response. Let's log this on the console. Response. Now, back in the browser, let's submit the registration form and then look in the console. So here's the response we get from the server. So far, we have looked at the data and status properties. We also have headers. So these are the headers that we receive from the server. However, in this list, all you can see is content type, which is set to application JSON. Our custom header is not here. And this is a common issue that a lot of React developers face. To fix this issue, we need to go to our backend implementation and set an additional header in the response. So here on this terminal window where we're running our backend, let's stop this process using Control and C. Now we need to open this project, Vidly API node, in VS Code. So here's our Node project. Don't worry if you have not worked with Node before, just follow the step I'm going to show you. It's very easy. We're going to write only one line of code. So under the routes folder, open users. So this is the implementation of our users endpoint. Here down the bottom on line 13, we have router.post. So if we send an HTTP post request to our web server, this function will be executed. Now, as you can see on line 27, we are setting a custom header that is x-auth-token. But in order for the client to be able to read this custom header, we should set an additional header that's a standard HTTP header. So dot header, we call this method and pass two arguments. The first one is the key. We set this to access dash control dash expose dash headers. This header lets a web server whitelist the headers that the browser or the client is allowed to access. So we set this to x-auth-token. So here we're using Node as the backend of this project. In your projects, you might use ASP.NET Core, Django, or any other frameworks. You need to add this standard header so the client can read this custom header. Okay, so save the changes. Now back in the terminal, we need to restart our web server. So node index.js. Okay, our web server is listening on port 3900. Beautiful. Now, once again, I'm going to submit our registration form with a unique email, register. Now in the console, look at our response object. Let's expand headers. Now we have our custom header. So this is our JSON Web Token. We can simply read this and store it in the local storage. So back in our register form, once again, we call local storage. That set item, we set the key to token and the value to response.headers. Here we can use the bracket notation to access this property, x-auth-token. And finally, we'll redirect the user using this.props.history.push to the home page. So let's test the application. Back in the application tab, here in the local storage, I'm going to delete the existing token. Now let's fill out the registration form with a new email address. Let's say user@domain.com with this password and this username. Register. We are redirected to the home page. Beautiful. Let's take a look at our local storage. So here's our token. And now our user is automatically logged in upon registration. Now let's see what a JSON Web Token really is. So here in our local storage, let's copy this JSON Web Token. Now let's head over to jwt.io. This is a main website for working with JSON Web Tokens. It has a very comprehensive introduction to JSON Web Tokens. It clearly explains how these tokens work, but you're going to learn about these throughout this section as well. We also have a bunch of libraries for different platforms. With these libraries, you can generate and validate JSON Web Tokens. For example, in my Node course, I use one of these libraries to generate these JSON Web Tokens when the user logs in. In your applications, you might use a different backend technology. You might use ASP.NET Core, Django, or whatever. You can always come back here and find the library for the platform you are using. Now, what I want to show you in this lecture is this debugger. With this debugger, we can decode a JSON Web Token and look at its content. So here on the left side, let's paste this JSON Web Token that we just copied. On the right side, we can see this JSON Web Token has three parts. The header, that is the part in red. And this is pretty standard. All tokens have that. We never have to worry about this. The second part is the payload. So what we have on the left side in purple, this is the encoded version of this JSON object. So that's why we call this a JSON Web Token. It's a JSON object that is encoded using base 64 URL algorithm. So here in the payload, we have properties like ID of the user, their name, their email, and the time this token was generated. That's why earlier I told you that a JSON Web Token is like an identification card. like your driver's license or your passport, it has various attributes about the user. We refer to these attributes as claims. So this token is claiming that this user, their ID is this value, their name is Mosh, their email is whatever. These are claims about a given user. Finally, the last part, the part in blue, is a digital signature that is generated based on the header, the payload, and a secret that is only available on the server. So this prevents a malicious user from getting their own JSON Web Token and then modifying their ID to pretend to be someone else. Because the moment you modify any of these properties, this digital signature needs to be regenerated. And as I told you earlier, in order to generate this digital signature, we need a private key, a secret. And this is only available on the server. So unless a hacker gets access to the server and finds the private key, they cannot modify their JSON Web Token to pretend to be someone else. So this is the basic idea about JSON Web Tokens. Now, what is interesting here is that in the payload, we have attributes about the user. So we can decode this JSON Web Token, extract these attributes, and then we can easily display the user's name on the navigation bar. So this is the basic idea about JSON Web Tokens. Now, what is interesting is that here in the payload, we have some basic information about the user. So we don't have to query our database every time we want to find out the user's name or email. All these basic information are included in our JSON Web Token. So next, I'm going to show you how to get this JSON Web Token from the local storage, decode it, get the payload, extract the name of the user, and display it on the navigation bar. All right, now let's open up app.js. So here in this app component, it would be nice to have the current user in the state. And then when rendering the navigation bar, we could easily pass the current user as a prop. We could also pass this user to any other components in our component tree. So let's add a state property here. We initialize it to an empty object. And then we implement component did mount. In this method, we get our JSON Web Token from the local storage, decode it to get the current user, and then we'll update the state. So first, let's call local storage.getItem. Our key is token. So this returns a JSON Web Token. Now we need to decode this. For this, we're going to use a library called JWT decode. So open up the terminal and install JWT-decode version 2.2.0. Okay, beautiful. Now, on the top, we need to import a function from this module. So let's add another import statement. We import JWT decode from JWT-decode. So this module exports a default function, and we call that JWT decode. We can call it anything. This is the default object or default function that is exported from this module. Okay. Now see how I have organized my import statements. On the top, I'm importing objects from third-party libraries. After these, we are importing components from our application. And finally, we have our CSS modules. So it's a good practice to have some kind of organization in your import statements. Now, back to our component did mount method. Here we call JWT decode and pass this JSON Web Token. This gives us the current user object. Let's verify that. So user, save. Back in the browser, you can see the current user object on the console. So we have email, IAT, which is the time our JSON Web Token is generated, as well as the name and ID properties. So we have the user object. Now we need to update the state. So this, that set state, and we pass our user object. So as you know, this will cause our app component to be re-rendered. Now we can pass the current user to our nav bar as a prop. So here we set user to this, that state, that user. So this is the basic idea. Now we need to look at the edge cases. What if our application loads and we don't have a JSON Web Token in the local storage? That is the case for anonymous users. So let's remove this token from our local storage and see what happens. Delete. Now refresh this page. Our application crashed. Invalid token specified. So if we pass null, an empty string, or an invalid JSON Web Token to this decode function, we'll get an exception. To solve this issue, we need to wrap these few lines in a try-catch block. So try, remove everything here, and then if we have any errors, we'll just ignore that. Because technically this is not an application error, this is only to handle the scenario where we don't have a valid JSON Web Token in the local storage. So save the changes. Now back here, our application is working, beautiful. So next we're going to modify our navigation bar. If the user is not logged in, we'll display the login and register links. Otherwise, we'll display the user's name along with a logout link. In the last lecture, we passed the current user as a prop to our navbar component. So now let's go to the navbar component. Here we have a functional component. We can either add props as a parameter to this function or use object destructuring to get the user property immediately. Now with this, we can render these two links, login and register, conditionally. So I'm going to select these two nav links, put them in an expression, and to conditionally render them, I'm going to write an expression like this. Not user and. So if we don't have a user, then we'll render the login and register links. Now here we have an error. JSX expressions must have one parent element. So we need to wrap these two nav links inside of a React fragment. So let's put this on a new line. Now let's add react.fragment and then close it right here. Save the changes. This is the final result. Now we need a similar structure for the scenario where we do have a user. In that case, we want to display the user's name and the logout link. So I'm going to duplicate this entire expression like this. So here's our first one. Here's the second one. We need to change the second one like this. We remove the not operator. So if we do have a user, then we want to render the user's name. So instead of login, we want to render user.name. And maybe when the user clicks on this link, we want to take them to the profile of this user. So let's change this address to profile or my profile or me, whatever you want to call it. And for the second link, instead of register, we want to have log out. And we should also change the address accordingly. Save the changes. Now currently I'm logged in, that's why you can see my name here as well as the logout link. We haven't implemented the logout feature, we'll do that next. But for now, to manually log out a user, we have to go to our local storage and remove this token. Now back here, let's refresh the page. So we see the login and register links when the user is not logged in. There is just a tiny issue in our implementation. Let me show you. So if we go to the login page and log in with a valid username and password, see what happens. Login, we get redirected to the home page. However, we still see the login and register links. But if we refresh the page, the problem goes away. Let me explain the reason. Here in the app component, we're getting the JSON Web Token from our local storage and decoding it inside of the component did mount method. This method is called only once during the life cycle of our application. Because our app component is mounted once, and then whenever we change its state, it's re-rendered. So to solve this issue, we need to go back to our login form. Here on line 26, instead of using the history object to take the user back to the home page, we need to do a full reload of the application. So we need to change this line to window.location. We set this to the home page. So this will cause a full reload of the application. As a result, our app component will be mounted again. Now we have a valid JSON Web Token in the local storage, so we decode it and get the current user. We have to do the same technique in our register form. So let's go to register form. Once again, on line 30, instead of using history, we should use window.location. We set this to the root or the home page. Now, to make sure that this works, once again, let's go to the local storage, remove this token. Now, refresh the application. So I'm an anonymous user, and that's why I see the login and register links. Let me log in one more time, user1@domain.com. Now I'm redirected to the home page, and we have my name and the logout link here. Beautiful. Next, we'll implement the logout feature. Now we want to implement the logout feature. This is pretty easy. Earlier I told you that if we delete this token from our local storage, the user gets logged out. So basically, if we have a valid JSON Web Token in our local storage, that means the user is logged in. Otherwise, that means they're logged out or anonymous. So to implement the logout feature, we need to register this new route. At this route, we need to render our logout component. That's a new component that we are going to create in this lecture. And when this component is mounted, we're going to delete this token from the local storage and then take the user back to the home page. So in our components folder, let's add a new file, logout.jsx. On the top, we should import React and the component class, and then create a class component called logout. We don't need any state, so delete. We're not going to render anything, so we'll simply return null. Now we need to implement component did mount. Here we should remove that token from the local storage. That's pretty easy. So local storage dot remove item. And here we pass the key, that is token. Finally, we should redirect the user to the home page. So we set window.location to the root URL. And with this, our entire application will be reloaded, our app component will be mounted again, and our navigation bar will be refreshed accordingly. So that's our logout component. Now let's go to the app component and register a new route. So here's the route for our login page. Let's duplicate this, change the path to logout, and the component to logout. So here you probably noticed that my auto import plugin worked properly. So we got an import statement for this logout component. However, as you can see, this is not consistent with how we have organized these import statements. So I'm going to move these to the top where we are importing all the components in this application. Now let's test our logout feature. So currently I'm logged in. Now let's log out. You can see I'm redirected to the home page. We no longer see my name and the logout link. And if you look at the local storage, my token is gone. So we have implemented these login and logout features, but there is a problem with our implementation. Look at our app component. Here in component did mount, we are working with this item in the local storage. The key of this item is token. And we have repeated this in a few different places. So if you look at login form, here on line 25, again, we're accessing this item with the key token. The same goes for our logout component. Once again, we're working with this item with the key token. If tomorrow we decide to change this key to something else, there are multiple places in our application that we need to modify. Technically, we should have only a single module where we have the implementation of authentication. Anything about authentication should be implemented in that module. Now, currently, we do have a module for that. Let's take a look at auth service. So in this module, we only have a login method, and all we're doing here is sending an HTTP post request to the server. Ideally, we should move the logic of storing the token in the local storage or removing it inside of this auth service. So this way, this module will be the only module in our application where we know how authentication is implemented. Right now, this responsibility is scattered all over the place. A part of that is in our login form, another part is in our app component, and so on. So let's refactor this step by step. First, let's go to our login form. We should move this line into our auth service. So cut. Now back to our auth service. This is our login method. Here, instead of returning this promise, we need to await it to get the response. And from the response, we're going to get the data property and rename it to JWT. Now let's paste the line that we cut. So we send an HTTP request to the server. We get the token and store it in the local storage. Now, because we have used await here, we should mark this function as async. With this change, we can go back to our login form and simplify this implementation. We no longer need to extract the token from the response, so delete. That is better. Now, you might be curious why I didn't move this line in our login function. Because this is really outside the scope of logging in a user, what happens after is the responsibility of the consumer of this login function. Maybe in one component, we want to redirect the user to the home page after they're logged in, but in another component, we want to display a toast notification. So what happens after the user is logged in is not the responsibility of the login function, okay? Now let's go to our logout component. Here, we should cut this line for removing the token. Cut. Now, back to the auth service. We should export another function, call it logout. And here we simply remove the token from the local storage. That is better. With this, we go back to our logout component. On the top, we should import the logout function from services/auth service. And then here we'll simply call the logout function. What happens when the user log out is not the responsibility of this component. Maybe we should delete something from local storage. Maybe we should call the backend. What happens is the implementation detail. It should not be part of the logout component, okay? Now, I personally prefer to implement this in more of an object-oriented way. So instead of importing a function here, I would rather to import an object like auth, and then here call auth.logout. I personally prefer this syntax. To make this happen, we should go back to our auth service and export a default object. In this object, we'll add the login and logout functions. Okay. Now, similarly, we could go back to our login form on the top where we are importing our auth service. Instead of importing the login function, we import an object called auth, and then here we call auth.login. That is better. Now let's go to our app component. Similarly, we should move this logic to our auth service because this is the implementation detail of getting the current user. This app component shouldn't know where the token is stored or decoded. This is all about the detail. Ideally, app component should tell our auth service, hey, give me the current user. We either get a user object or null. As simple as that. We don't even need this try catch block here. So I'm going to cut this code from here, go to auth service, and create a new function. Call it get current user. Now paste this code. In this function, we have our try block. We get the token from the storage, we decode it, but we are not going to update the state because that's the responsibility of a component. So let's cut this line from here. If we can successfully decode this token, we get a user object. So we simply return that here. Otherwise, if we get an exception, we're going to return null. That means we don't have a current user. Now let's add this function to the default object that we're exporting here. Get current user. Save the changes. Back in app component, here we need to import our auth service. So right after we import all the components, we'll import any services that we need. In this case, auth from services/ auth service. And then in component.mount, we call auth.getCurrentUser. We get a user object, which can be null, and then we'll call this .setState. Isn't that cleaner? It's much better. The details of getting the current user are not implemented here. They are somewhere else. Now, also, we should go on the top. We no longer need to import this function. In fact, our app component shouldn't really care about decoding a JSON web token. This is implementation detail about authentication. So all these details should be in our auth service. So we're going to cut this line from here and move it on top of our auth service. Finally, the last part that we need to refactor is our register form. Once again here, we are directly working with the local storage. We want to push this to our auth service. So we register a user using the user service, and then we need to tell our auth service to store the token. Currently, in our auth service, we have a login function or a login method that takes an email and password. We need another function or another method here that will log in the user using a JSON web token. So in that function, we're not going to call the server. We'll simply store the token. So let's export another function, call it login with JWT. We pass a JWT, and here we simply call local storage.setItem. Now we need to add this new function to the default object we are exporting. So login with JWT. Now technically we don't need to export these individual functions because we're exporting this default object and we can access any of these functions using this object. But we can keep them here in case we want to import only a single function in another module. So save the changes. Now back in our register form, on the top we need to import our auth service. So import auth from services/auth service. Now you see we used a different syntax for importing a user service. That is a little bit ugly compared to how we're importing the auth service. So potentially in the future, we can modify this user service and export a default object so we don't have to add this extra part when importing this user service. For now, let's not worry about this. Back to our registration form. So here, instead of calling local storage.setItem, we should call auth.login with JWT. And we remove the first parameter. Good. So now if you look at our auth service, there is a single place where we're working with this local storage. If tomorrow we decide to rename this to something else, we only have to come back and modify this module. Now to make this code even better, we can replace all occurrences of this token with a constant. Let's call that constant token key. And then here we can initialize it on the top. Token key set to token. This way, this is not repeated 4 times in this module. So here in the terminal window for our Node server, let's stop this server and open this project in VS Code. Here in the config folder, open up default.json. Earlier, we set requires auth to false. Now we're going to turn this on, so the user has to log in order to create, update, and delete a movie. Now, back in the terminal window, let's restart the server. Now, if you're a Node developer, you probably know this library called nodemon. With that, you don't have to stop and restart the server every time. That's it. Okay, our Node server is listening. Beautiful. Now, back in the browser, let's see what happens when we try to edit an existing movie. So we can make any changes here. Click Save. Nothing happens. If you look at the Network tab, you can see our request failed. And the status is 401, which means unauthorized. That means this API endpoint required the client to send a JSON web token, but the client didn't send that. To fix this issue, we need to go back to our React application. So here in VS Code, let's open up HTTP service. As I told you before, this module is responsible for making HTTP calls to the backend, and this is the only place where we're configuring Axios. So if tomorrow we decide to make any configuration changes, there is only a single place we need to modify. Now here we're going to add another line of configuration for configuring default headers. So we're telling Axios that, hey, whenever you want to send an HTTP request, make sure to include this header in the request. So we type axios.default.headers.common. With this, we can set headers on all kinds of HTTP requests. That is GET requests, POST requests, and so on. We also have other properties like POST, and with this, you can configure headers that are applicable on HTTP POST requests. So back to common, here we use bracket notation to set a common header, that is x-auth-token. Now here we need to get the user's token from local storage. But as I told you before, here we don't want to directly talk to local storage. We're going to use our auth service because that's the only module, the only service that knows where these tokens are stored. So let's import auth from auth service. Now we call auth. Currently, we don't have a method to get the token. We have get current user, which actually returns a user object. So we need to add another method in this module. Let's open up auth service. And here we export another function called getJWT. And in this function, we simply return local storage.getItem and pass token key. And finally, we need to add this to our default object. So getJWT. Done. Now back in our HTTP service, we call auth.getJWT. Beautiful. So now whenever we have an HTTP request, this token will be included. If the user is not logged in, token will be undefined, so this header will not be set. Okay? Now let's test the application one more time. So back to our movie form, save. Our application is working. Beautiful. In the last lecture, we wrote this line of code to fix the issue with calling protected API endpoints. Our application is working. However, we have created a very common and also dangerous design issue. This is called bidirectional dependency. So if you look at our HTTP service, you can see on the top, we have a dependency to our auth service. And at the same time, if you look at the auth service, you can see we have a dependency to the HTTP service. So we have a bidirectional dependency. We need to get rid of this. Otherwise, eventually it's going to come to the surface and give us a really bad pain. So how can we do this? Well, first we need to determine which module is more of an essential or a core module. In this case, our HTTP service is more of a core module because if we cannot make HTTP connections to the backend, the authentication doesn't even make sense. So our auth module should be on top of the HTTP module. Okay? So back to our HTTP service module, we should remove any dependencies to our auth module. We delete this from the top. However, on line 5, we need to get our JSON web token. So how do we do this without having a dependency to our auth module? Well, we can reverse this statement. So instead of HTTP service telling auth service, hey, give me your JSON web token, we can go to our auth service and tell HTTP service, hey, here's my JSON web token. So we reverse this statement. So let's cut this line from here. In this module, we should add another function. Call it setJWT, which takes a JSON web token. Now let's paste this line here. Instead of getting this from our auth module, we're going to use this JWT argument. And then we should add this function to our default object that we are exporting from this module. So setJWT. Good. Now we go back to our auth service. So on the top, we are loading our HTTP service module. Here, we can call http.setJWT JWT, and then we can pass our JSON Web Token. Currently, we have a function to get that, so we can call get JWT. As simple as that. So this is how we get rid of bidirectional dependencies. So we fixed the issue with updating movies. However, currently we cannot delete a movie. So if I delete this movie, nothing happens. Here on the network tab, you can see our request failed with error 403, which means forbidden. This is because I have implemented the backend of this application such that only admins can delete a movie. Before I show you how to fix this problem, let's have a quick look at the backend implementation. So here in our Node project, inside the routes folder, let's take a look at the movies module. Here on line 67, we're setting up a route handler. So we're telling Express, which is the framework used to build this backend application, that, hey, if you get a delete request at our movies endpoint, make sure that the client is authenticated and is an admin. So this auth and admin that you see here, these are two functions. We refer to these functions as middleware functions. Let's have a quick look at the implementation of these. So back in the project, inside the middleware folder, let's take a look at auth.js. So you can see auth is a function. In this function, first, we check our config to see if authentication is enabled or not. If it's disabled, we simply pass control to the next middleware function. Otherwise, we read this header from the request, that is our x-auth-token header. If we don't have a token, we return a response with status 401, which means unauthorized. And here's our custom message, access denied, no token provided. Otherwise, if we do have a token, we need to validate it. So over the next few lines, we try to validate the token. And if it's valid, we pass control to the next middleware function. Otherwise, we return a 400 error to the client, which means invalid token. So technically 400 represents bad requests. So we're telling the client, hey, this is a bad request because you sent us an invalid token. So this is our auth middleware function. Now let's take a look at our admin middleware function. So once again, in the middleware folder, this is admin. Here you can see this is also a function. At the beginning of this function, we check our configuration. If authentication is disabled, we simply pass control. We don't care. We don't do anything. Otherwise, we check to see if the current user is an admin. So our user has a property called isAdmin. If this is faulty, we return a response with this status 403 with this message, access denied. And this is exactly what we got here. 403, which in standard HTTP terms means forbidden. And here's the message that we included in the body of the request. So in this case, our client did send a valid JSON Web Token, but the current user is not an admin, and that's why the server didn't allow this operation. So how can we fix this issue? Well, we need to go back to our database and set this property of our user object to true. So here in MongoDB Compass, this is my user account. Let's edit this and add a new property called isAdmin. We set it to true. Now note that by default, the value is a string. We need to change that to a Boolean and then update. So now I made this user account an admin, so I should be able to delete a movie. However, if we try to delete this movie, it still doesn't work. Let me show you why. Back in our local storage, I'm going to copy our JSON Web Token, take it to jwt.io and decode it. So this is the payload of our token. We have ID, name, and email. These are the properties of the user that are included in this token. So when we send this token to the server decodes this, it extracts these properties, and with this, it constructs the user object. This user object does not have the admin property because this token was generated before we updated this user in the database. So to solve this issue, we need to log out, log back in again, we'll get a new token, and when we decode that token, we will see that this user is an admin. So back in the application, let's log out and log back in. All right, now we're logged in. Here's our new token. Let's copy this. Back to jwt.io. Let's paste that here and look at the payload. Now we have this property, isAdmin to true. With this, we should be able to delete a movie. So back in our application, delete. Beautiful. Now, what if a malicious user who is not an admin gets their token from the local storage, brings it here, edits it, set their isAdmin property to true, and then put the token back in the local storage? Well, that wouldn't work because, as I told you before, every token has a digital signature, and this signature is generated based on the content of this token. So if we make any changes to this payload, if we add one extra character or remove one character, this signature needs to be regenerated. And in order to generate this signature, we need a private key. This private key is stored on the server. So unless a hacker can access the server, they cannot regenerate this digital signature. And one last thing before we finish this lecture. In this demo, I manually made this user an admin. In your applications, you might have a complete user interface for managing users and their permissions. That's beyond the scope of this course. But generally speaking, the first time you deploy an application, you should have at least one admin user. You may manually make someone admin by connecting to the database, or you may automate this using a script. Quite often, we want to hide certain elements if the user is not logged in or doesn't have certain permissions. For example, on this page, we want to hide this new movie button if the user is not logged in. We also don't want to give them the ability to edit a movie or delete a movie. So in this lecture, I'm going to show you how to hide this new movie button. You can use the same technique to remove this link as well as the delete column in this table. So let's go to app.js. Earlier, we introduced this user object here and passed it down to our navbar component. We can use the same technique, pass our user object to our movies component, and there we'll decide to show or hide various elements depending on this user object. So here we're using route component, so we cannot pass this user object here like this. I explained this in the section about routing and navigation. So in order to pass additional props to this child component, we need to use the render attribute. So we replace component with render. Here we pass a function that takes props and returns the movies component like this. Now we need to add all these props here. This is essential because these props include history, match, and other props that React automatically injects when we use routing. In addition to these props, we want to pass another prop that is our user object that we get from this.state. That's it. So with this, we can go to our movies component. Movies component. Here in our render method, let's extract the current user from this.props. And then we can simply show or hide the new movie button depending on this user object. So here is our button. We put this in an expression, and here we check if user is truthy, and then we have this link component. Save the changes. So currently I'm not logged in, and that's why we don't have this button here. If I log in with user1 or any other accounts, the button comes back. Log out, it disappears. Beautiful. In the last lecture, we hid the new movie button, but we can still access that page. So if I go to /movies/new, look, we can access this form without even having to log in. So in this lecture, I'm going to show you how to protect this route. So here in the app component, this is the route for our movie form. We're going to use the same technique we used in the last lecture to protect this route. So instead of using the component attribute, we're going to use the render attribute. Here, because we can pass a function, in that function, we can check to see if the current user is null. If that's the case, we'll redirect the user Otherwise, we'll render the movie form component. So let's put this on a new line and then rename component to render. Here we pass a function that takes props. Now in the body of this function, we need to check if user is falsy, we will return the redirect component. Redirect to where? To our login page. Very easy, right? So if the user is falsy, we'll redirect them to the login page. Otherwise, we will render our movie form component with these props. As simple as that. Let's test the application. We got an error here. User is not defined, which makes perfect sense because obviously we have not defined user in this function. So here in the render method, let's do our object destructuring and get this user from this .state. With this, we can also simplify this code so we don't have to repeat this .state multiple times. Now back in the browser, you can see I'm redirected to the login page. So once again, if I try to access /movies/new, I get redirected to the login page. Now in the future, I will show you how to add the redirect URL. So the moment the user logs in, we'll take them back to where they came from. So this is how we can protect a route. However, this is not an easy solution to reuse in multiple places. We don't want to repeat this logic every time we have a route component. So in the next lecture, I'm going to show you how to build a reusable route component that is aware of the current user and can automatically redirect the user if they are not logged in. So when we use the route component, we supply a path and either a component or a render attribute. In this lecture, I'm going to show you how to create a new route component. We're going to call this protected route. This component has the exact same interface as the route component. So it takes a path and either a component or a render function. But this protected route is aware of the current user. So if the user is not logged in, it will automatically redirect the user to the login page. So we don't have to repeat this logic for every single route that needs to be protected. All right, now let me revert this back to what it was. Here in the components folder, under common, let's add a new component. We call this protected route.jsx. Here we import React on the top and create a functional component called protected route. This function takes props. Now here we'll simply return a route component. So similar to what we have here. So wherever we use the protected route component, the output of that component will be a standard route component in React Router. So we can simply copy this code from here and paste it in this function. However, we don't want to hard code this path and this logic for returning a movie form. We want this part to be dynamic. So instead of setting the path to this hard-coded value, we can read this from props. So here I'm going to use object destructuring. Let's pick path from our props object and use that as the value of this path attribute. Now here in this render function, we need to know about the current user. We can get this from our auth service. So on the top, let's import auth from. We go 2 levels up. Then in the services folder, pick auth service. And then we'll change this to auth.getCurrentUser. So if this is falsy, we need to redirect the user to the login page. Now here we have used the redirect and route components, so we need to import them on the top. So import route and redirect from React Router DOM. That's good. Otherwise, if the user is logged in, we want to return a component dynamically. So instead of movie form, we need to pick the component attribute from our props object, component, and render that here. However, If we run this code, React is going to complain because React expects components to start with a capital letter. So we cannot have an element like this. To fix this issue, we need to rename this component to component with capital C, and then render that here. Now, as I told you before, when we use the route component, we either supply a component or a render function. So back to our protected route component, it is possible that this component is null. So we should also pick the render function from our props object and change our return statement to something like this. If component is truthy, we'll return that. Otherwise, we'll call the render function and give it this props that we receive here. So props. We're almost done. There is just one tiny bit left. So here we're picking path, component, and render properties from the props object. As you know, it is possible that this object might have other properties. So using the rest operator, we should pick the other properties, call them rest, and also add them to our route component. So using the syntax that you have learned before, we'll simply add any additional properties here. Now we can simplify this code. So instead of setting path to path, we can rely on spreading the rest object. So let's delete line 8 and we are done. Now back to our app component. Here we want to replace this route component with a protected route. So let's change this, protected route. You probably noticed that my auto import plugin imported this component on the top. Here it is. However, it's placed at the end of all import statements. I would prefer to move this up next to other components. Now, back to our protected route. So we set the path, but instead of setting the render function and checking if the user is logged in or not, we simply set the component to movie form. This is exactly what we had before. So let's get rid of this render attribute, save the changes. So now our protected route is aware of the current user. Let's test the application. So currently I'm not logged in. Let's go to movies/new. You see, I automatically got redirected to the login page. Let me log in with this user. Good. Now, as a logged in user, I should be able to create a new movie or edit an existing one. Beautiful. So currently I'm not logged in and I try to edit one of these movies. I get redirected to the login page. Now, when I log in, I get redirected back to the movies page, not the movie form. So we need to modify our login form and redirect the user back to where they wanted to go. Here in our protected route component, if the user is not logged in, we redirect them to the login page. So here we need to pass some additional data. That is the current location or where the user wanted to go. How can we get this? We can get it from this props object. So in this render function, let's quickly log this props object. Now I'm going to log out and try to edit this movie one more time. Here in the console, look at our props object. We've got history, location, and match. As you have learned, React Router automatically passes these props to our components. Now look at the location property. This object represents the current location before we got redirected to the login page. So this is where we wanted to go, and basically we can pass this location object to our redirect component. Now before we do that, let's quickly look at React Router documentation. On this page on the left side, look at this redirect component. As you can see, the two attributes can be a string or an object. This object is a location object with these properties. So we have path name, search, and state, which we can use to pass any additional data in the component we are redirecting the user to. That is our login component. So back to our protected route component. Instead of setting this two attribute to a string, we need to set it to a location object. So let's delete this. We'll set it to an object. In this object, we should have two properties. One is path name, which should be /login, just like before. But we should also set the state property. That is the property we use for passing any additional data. We set this to an object, and in this object, we can add a property like from, and we set this to props.location. Because this location object represents the current location before we redirect the user to the login page. So that was the first part. Now we need to go to our login form component and see if state is set. If it's set, we'll redirect the user back to where they wanted to go. So let's delete this console.log, save the changes. Now let's go to our login form component. So here on line 25, this is where we are redirecting the user to the home page. We need to make a small change here. So we get the location object, this.props.location. Now, as you saw, this location might have a state property. So we can use object destructuring to pick the state property. Now we need to change line 27 to something like this. If state is defined, we'll pick state.from. That is the custom property that we set here. So we set state to an object with a property called from. This from is a location object, and location objects in React Router have a property called path name. So back to the login form, we pick state.from.path name. Otherwise, if state is not defined, we will redirect the user to the home page. That's all we had to do. Let's test the application. So currently I'm not logged in and I try to edit this movie. I get redirected to the login page. Let's log in, user 1. Now the application redirected me to the movie form. Beautiful. Now let's test the other scenario. This time I'm going to directly go to the login page and I expect to be redirected to the home page. Beautiful. Now there is one tiny issue in our application. Even though I'm currently logged in, I can still go to the login page. And that is not right. So in this case, we want to redirect the user to the home page. Back to our login form, here in the render method, we can do something like this. If the user is logged in, so if auth.getCurrentUser is defined, we will return a redirect component to the home page. Like this. Otherwise, we'll return the login form. Now, because we have used the redirect component, we need to import it on the top. So import redirect from React Router DOM. You might be curious why I didn't use window.location here, because we use that only when the user is trying to log in. So we want to reload the application so our application is remounted and is in the right state in terms of knowing the current user. So save the changes. Now I try to go to /login and I get redirected back to the movies page. Beautiful. I want you to modify this application and show this delete button only if the user is logged in and is in the admin role. That's fairly easy and should take about 5 to 10 minutes of your time. You will see my solution next. Here in our app component, currently we're passing the user object down to the movies component. So our movies page knows the current user. Now let's take a look at our movies component. So movies JSX. Here we're using the movies table component. Now you can also pass the user object as a prop to this component, but that is kind of tedious and ugly. There is really no need to pass this user object down our component tree all the time, because we can always get it from our auth service. So for this exercise, we're going to get the current user from our auth service, and potentially in the future, we can come back and refactor our application so we don't have to pass this user object down the component tree all the time. Okay, now let's go to our movies table component. On the top, we need to import auth from services/auth service. Now in this component, we have this columns array. The last column here is the delete column. There are various solutions to hide this column if the user is not an admin user. One solution is to add an additional property here, like visible or hidden, that we can dynamically set, but that solution requires modifying multiple components to add support for hiding or showing columns dynamically. Another solution is to exclude this column from this array and only add it if the user is an admin user. In this case, this solution is simpler, so we only have to change this movies table component. We don't have to write a lot of extra code to add support for showing or hiding columns dynamically. So always pick the simplest solution that helps you deliver working software. Remember, simplicity is the ultimate sophistication. So I'm going to cut this code from here. Now we add a constructor. In this constructor, we need to get the current user. So we define this constant and set it to auth.get current user. Now, potentially in the future, we can also refactor this code. So instead of having a method here, we could have a property like current user. This way, we don't have to use parentheses and we don't have to call this get current user. But that's a different topic. You should discipline yourself to focus only on a single task at a given time. There are always ways to improve our code. We don't want to get lost in all these endless refactorings. Once again, we should deliver working software with clean code. So we get the current user. Now, if this user is truthy and is an admin, then we'll push this delete column to our columns array. So this.columns.push, and then we can paste the code that we copied. However, this implementation is messy because it has polluted our constructor. Our constructor should be very simple and clean. So to fix this problem, we can define another property, call it delete column, and set it to this object, to this delete column, right? And then in the constructor, instead of pasting this delete column, we can reference this.delete column. See, you can read this code like a newspaper. If the user is an admin, add the delete column to the columns array. The details of this are not polluting our constructor. So save the changes. Now there's one more thing we need to add. Because we have added a custom constructor, we should also call the constructor the parent class. So save the changes back in the browser. Currently, I'm not logged in. That's why we don't see the delete column. Let me log in with a user who is an admin. Here's our delete column. Beautiful. Let me log out and log in with a user who is not an admin. So always test the edge cases. Once again, we don't see the delete column. Earlier, we added this config.json to store our configuration parameters. That was a quick and simple solution. It worked well. However, the parameters that we set here are not environment specific. Every application goes through multiple environments: development, test, and production. Sometimes we want the value of these parameters to be different across different environments. For example, on our development machine, we want to use our development backend, but when we deploy this application to a production environment, we want to use a real production backend with real data. So this config.json is not going to help us with that. However, the applications that we generate with Create React App have built-in support for environment-specific variables. Let me show you how to work with them. So close this. Here in the root of the project, we add a new file with extension .env. Note that this file doesn't have a name, it's just an extension. In this environment file, we can store all our environment variables with their default values. We can also have environment-specific files. So here we add a new file, .env.development. We could also have .test and .production. So here in this file, we'll store all our development environment variables. All these variables have a key and a value. The key should start with React _app _. If you don't use this prefix, what I'm going to show you is not going to work. So let's set a couple of variables here. The first one is name. We set this to vidly in dev. We can also set version Now to read these, let's go to one of our JavaScript files. For simplicity, I'm going to go to index.js. But what I'm going to show you, you can do that in any JavaScript files. So here, let's do a console.log of process.env. If you have worked with Node before, you have seen this object. So process represents the current process, and env is a property of this object that represents all the environment variables. These environment variables can be set directly in terminal, or they can come from these configuration files. Now back to index.js, save the changes. Here in the terminal, we need to restart our application because at the time we launched this application, we didn't have these environment files. And anytime we make any changes in these files, we have to restart our application because they are not watched. So stop the server and launch it again. All right, here in the console, look at our process.env object. So we have a couple of built-in environment variables, node env, which is set to development, and this will change automatically to production when you build a production-ready package. We'll get to that shortly. You also have public URL, and here are the two environment variables that we define, app name and version. Now back in index.js, in order to get the application name, we should get this property of the environment object, React app name. Now here I'm going to add a label, and you will see that why in a second. Let's call this Superman. You'll see why in a second. So here in the console, you can see our application name. But what is this Superman here for? Well, let's go to the Sources tab. Here on the left side, you can see our domain. Let's expand the static folder under JS, open up bundle.js. So this is the main bundle that includes all our JavaScript code. Here we want to search for Superman. So press Command and F on Mac or Control F on Windows and search for Superman. Here is our console.log statement. But look at the second argument we pass to the log method. It's not process.env.react app name. It's the actual value of that environment variable. So the expressions that reference an environment variable are replaced by the actual value of that environment variable during build time. So here in the terminal, when we run npm start, that's when the build process happens. All the environment variables that we stored directly in the shell or in our configuration files are extracted. And then wherever we have process.env.something, that expression is replaced with an actual value. In the next lecture, we'll look at building for production. So you have learned that we use npm start to start our application. This will give us a development build, which is not optimized because the JavaScript bundle that it generates includes additional code that helps us debug our application. But when we deploy our application to production, we don't want all that extra code. We want an optimized production build. To get that, we run npm run build. So this is going to create an optimized production build. It's going to take a few seconds, so I'm going to pause the recording. Now in our project, we have this new folder, build. This is our optimized production build. And you can basically get the content of this folder and send it to your web server using FTP or any other tools. Starting from the next lecture, I'm going to show you how to deploy this application to Heroku, which is an amazing cloud service. Now, back in the terminal, here you can see this message. The build folder is ready to be deployed. To test this on your machine, you can install this npm package serve. This is a simple, lightweight web server. And with this command, you can serve the content of the build folder. Let me show you real quick. So npm install -g for global serve. And if you're on Mac and you haven't configured permissions properly, you should prefix this with sudo. Okay, I've installed serve. Now we can serve our production build using this command, serve-s build, which is the target folder. So this is serving our application at localhost port 5000. Now here in the browser, let's head over to localhost port 5000. open up the console, note that Superman is undefined. This is because we did not set a value for this environment variable for the production environment. We set this only in the development environment. So as I explained in the last lecture, during the build time, these expressions that reference an environment variable are replaced with the value of that environment variable. So when we run our application using npm start, we get the development environment variables. And when we build it using npm run build, we get the production environment variables. We also have npm test for running tests. And when we execute this command, our test environment variables will be used during the build time. In this section, we're going to deploy our Vidley application to Heroku. If you have never worked with Heroku before, there are 2 steps you need to follow. First, you need to create a Heroku account. It's very simple, it's free, it only takes a few seconds. Then you need to install Heroku CLI. So search for Heroku CLI. Here's the first link. And on this page, you can find the installer for your operating system. You can see if you're a Mac user, you can install it with Homebrew, which is really easy. Once you install Heroku CLI, then open up the terminal and run Heroku-v. So as you can see, I'm using Heroku CLI version 6.13, but there is also an update available to version 6.15. Now, I'm not worried about this update because what I'm going to show you in this section works perfectly fine with either versions. So now you need to log in. So Heroku, login. Here you need to enter your email and password that you use when creating an account on heroku.com. So my account is programmingwithmosh@gmail.com. So you can see I'm successfully logged in. Now, chances are this step may fail on your machine if you are behind a firewall that requires the use of a proxy to connect with external HTTP services. If that's the case, you need to set an environment variable. So on Mac, we use export. On Windows, we use set. We set HTTP_proxy. And here you add your proxy server. Let's say HTTP proxy.server.com. And here you add the port number. Once you set that, then try logging in with Heroku login one more time. All right, you have set up a Heroku account. Now you need to set up an mLab account. We use mLab to deploy our MongoDB database in the cloud. It's a fantastic service and it comes with a basic free plan. So pause the video, head over to mlab.com, create a new account, and when you're done, come back, continue watching. So when you create an account and verify your email, this is what you're going to see. MongoDB deployments, currently we have none. So create this button, create new. Now here we have different providers. You can put your database in AWS, Google Cloud Platform, or Azure. The provider you use is entirely up to you. I don't have a strong opinion about these providers. So I'm going to go with AWS. Below that, you can see we have this sandbox plan type, which is completely free. Now, this sandbox in AWS is available in US East and Europe. If you use a different provider, you're going to see a different region. For example, let's look at Azure. So as you can see, Azure has sandboxes in West US, East US, and Dublin. So I'm going to go with this. Let's continue. Select the region. I'm going to use California. Then continue. Give our database a name. I'm going to use Vidley. Continue. And submit order. Now, this is not really an order. It's completely free. All right. Now we have a MongoDB database in the cloud. So let's click this. Here on this page, we need to create a user. So let's go to the users tab and click this button. I'm going to call this user Vidley user and give it the password of 1234 1234. Of course, this is a very bad password, purely for this demo. Create. All right, our user is ready. Now, on top of this page, you can see our MongoDB connection string. We're going to use this later in our Node backend. In order to deploy our application to Heroku, first we need to add our source code to a Git repository. Git is a very powerful version control system, so we can put our code in a Git repository and see how it's changing over time. We can look at the history of the changes, see who has changed what. Now, if you're not familiar with Git, don't worry, you don't have to be a Git expert in order to deploy this application. Just follow the steps I'm going to show you. But if you want to learn more about Git, you really need to take a separate course because that's an entirely different topic. So if you don't have Git, head over to git-scm.com. On this page, you can find the downloads. So get the installer for your operating system, install it. When you're done, open up a terminal window and run git --version to make sure you have installed Git properly. All right, now let's go to vidly-api-node. We're going to deploy our backend first, test it, make sure it works properly, and then we will deploy the front end. You could also combine these two projects and deploy them in one go, but that really goes beyond the scope of this course because I have to talk about some additional tools and scripts that are not very reliable and they break all the time. Also, take into account that in a lot of organizations, backends are built and deployed separately by a different team because you might have multiple front ends. One could be a web interface, another one could be an Android app, and so on. So that's perfectly fine to version and deploy the backend separately. Now, open up this folder in VS Code. Here in the root of the project, let's add a new file, .gitignore. We use this file to tell Git what files and folders should be ignored. One of the folders we want to ignore is node_modules, because this folder, as you know, includes hundreds of third-party libraries. We don't want to check these files into our Git repository because this will increase the size of our Git repository. So add node modules and make sure to add this / at the end because this will represent a folder. Now save the changes. Back in the terminal, run git init. This will initialize a Git repository in this folder. Now run git add period. This will stage all our files to be committed to the repository. So next we should run git commit -m to specify a message like initial commit. So put the message in double quotes. Okay. So all the files except the node modules folder is now committed to our Git repository. In the next lecture, we'll deploy this application using Heroku CLI. Now we are ready to deploy our application. So in vidly-api-node folder, first we need to create a Heroku app. So we run Heroku create. Now here we can pass an application name like vidly-api, but I'm not going to do this because these names should be unique. And if I run this command, you're not going to be able to create another application with the same name unless you add an extension here, which again can be a duplicate as more students watch this course. So we can leave this argument and let Heroku create a unique application name for us. So let's go ahead. All right, it's done. So here's the name of our application, Young Refugee. On your machine, you're going to get a different name. Below that, you can see the address of our application on herokuapp.com. So our backend will be hosted at this address. So our front end should send requests to this address /API/whatever. Now, next to that, you can see we have the address of a Git repository under heroku.com. So git.heroku.com, here's the name of our application, .git. What is this for? Well, you know that inside of this folder, we have a Git repository. And this repository includes all our latest source code. Now, we have another Git repository at this address. And then using only a single command, we can push or upload all our source code from our local repository to this remote repository. Whenever we push new code to this remote repository, Heroku will be notified. It will download the latest source code, build it, and then deploy it to this address. This is what we call continuous integration. Now, we want to push or upload the code that we have in our local Git repository to this remote repository. That is very easy. Git push Heroku master. So we're telling Git to push to Heroku, and master is the name of our current branch. Because in a Git repository, we can have multiple branches, we can use these branches to work on different features or different bug fixes. That's beyond the scope of this course, and that's something you need to learn in the Git course. So let's go ahead and run this command. All right, we successfully deployed our application to Heroku. Now we can open it using Heroku open. This will launch your browser pointing to your application on Heroku. As you can see, here we have an application error. In the next lecture, I'm going to show you how to look at the logs to find and fix the errors. Here on Heroku dashboard, you can see our backend application. On the top, under More, we have this item, View Logs. This gives us a simple and clean user interface to look at the logs, but it doesn't always give us the details we need. My preferred way is to use the terminal. So here in the terminal, inside our backend project folder, let's run Heroku logs. If you scroll up, you can see why our application crashed. So here we have this error, Mongo network error, failed to connect to server at localhost port 27017. This is the default port for MongoDB. Now here in our backend project, inside of the config folder, open up default JSON. In this configuration file, we have this parameter DB, which is set to the address of our MongoDB on our local machine. Obviously, this does not exist on the Heroku server that is hosting our application. So we need to change this to the address of our MongoDB database on mlab. So here on mlab, this is our Vidly database. On top of this page, you should see our database connection string. As you can see, our database user and their password is part of the connection string. We don't want to store this in a configuration file like default.json because that password is stored as clear text here. It's going to be part of our repository. So anyone who has access to that repository will be able to get the password to our database and literally do anything they want. In fact, a little while ago, a big corporation in the US got hacked because someone stored a database password in the source code and that password ended up on GitHub. So never, ever, ever store secrets in your configuration files. Now, in this node project, we have this default.json, which includes the default values for these configuration settings. That is perfectly fine for a development environment. But for production environment, we should use environment variables. These environment variables are not part of the source code. We need to set them in terminal. So the first time a developer deploys our application, they're going to open up a terminal window and store these environment variables on the server. And that's what I'm going to show you in the next lecture. Now here on mlab, let's copy this connection string and temporarily paste it here so we can see it clearly. In this connection string, we want to replace db user with vidly user and db password with 1234. So we have the user, password, @, and then the address of our MongoDB database. Now let's cut this from here. Back in the terminal, we want to store this as an environment variable on Heroku. So we run Heroku config :set. We call our variable vidly _db and set it to this connection string. Done. So we can see we have this variable called vidly _db that is set to this database connection string. Now we need to make a tiny change in our application code and redeploy it so it can read the connection string from this environment variable. Here in this node project, I'm using a module called config, and this config module has a few conventions. Inside the config folder, we have this default.json, which includes the default values for our application settings. We can have another JSON file for our test environment, one for production, and so on. But we also have this specific JSON file, custom environment variables.json. And in this file, we map application settings to environment variables. So here we have an application setting, JWT private key, that we have mapped to an environment variable called vidly_JWT private key. So in our development environment, our application code is reading this application setting from default.json. So as you can see, its value is unsecure key. Similarly, our application code is reading our database connection string from this application setting, DB. And that's perfectly fine for the development environment, but for production, we want to read this from an environment variable. So we need to map this key to an environment variable. Back to our custom environment variables file, let's add another key value pair. The key is DB and the value is vidly_DB. That's the name of the environment variable that we set on Heroku, right? Save the changes. Now, before going forward, I just need to clarify that this implementation is purely specific to this node project because here I have used this config module and that's how everything works. In your applications, you might use a different module or you might not even use Node. You might use ASP.NET Core. But the concepts I'm teaching you here applies to your platforms as well. You need to modify your application code to read the database connection string from an environment variable. All right, now we have done with changing our source code, so we need to deploy it one more time. Back in the terminal, first we need to stage all the changes, then commit them to our repository with a message like added support for reading connection string from an environment variable. Now the changes are committed to our local repository. Finally, we need to push our code to this remote repository on Heroku. So git push Heroku master. As you saw earlier, this will notify Heroku to rebuild and redeploy our application. Now let's open it one more time. Heroku open. Unlike before, our application didn't crash. We just got this error message, cannot get, because there is nothing available at the root of this application. But if we head over to /API/genres, we should get something like this. Now on your machine, you're probably going to get an empty array unless you populated your MongoDB database on MLab with some data. The reason we have two objects here is because I populated this database prior to recording this video. So this verifies that we successfully deployed our backend to Heroku. Next, we're going to deploy our frontend. All right, now let's focus on the frontend. Earlier, we talked about this config.json and environment files. Before we deploy this application to production, we should make a few changes such that if this application is in the production environment, it's going to use a different backend. That is the backend that we're currently hosting on Heroku. So basically, we want to get rid of this config.json. So here in the root of the project, let's add a new file, .env.production. In this file, we should add a variable called React app API URL. We set this to the address of our backend app on Heroku. So copy this and paste it here, and then remove /genres from the end. So make sure this address ends with /API. Save. Now we need to set the same variable for our development environment. So copy this line and go to env.development. Let's delete all these, paste that here. In our development environment, we want to use a different address. That is what we currently have in config.json. So let's copy this address and then paste it here. Beautiful. So there are a few places where we have used this config.json. Here in the services folder, let's take a look at auth service. On the top, we're importing API URL from config.json. Let's delete this line and then change API endpoint to just /auth. We don't want that prefix. We're going to make the same change in other services, so I'm going to pause the recording. So as you can see, I've modified all these services except HTTP and log service. In all these services, wherever we had a reference to config.json, I removed that reference. Now we should go to our HTTP service and configure a default property. So on the top, axios.defaults.base URL. We set this to process.env.react.app API URL. So as you learned earlier, this will be replaced with a different value depending on how we are building this application, for development or for production. Save the changes. Now, before we deploy this application, we can create a production build, serve it locally, and make sure it's connecting to the backend that we have on Heroku. So here in the terminal, npm run build. Okay, our production build is ready. Now let's serve it. So serve-s build. So here in the browser, this is what we get. There are no movies in the database. Currently, we have a UX issue. So if the database is empty, we don't get that button to add a new movie. So let's go to movies.jsx. Here in the render method, we should remove what we have on line 101. If count equals 0, we don't want to return this message. Save the changes. We need to build the application one more time. So npm run build. And then serve it one more time. So back in the browser, these genres you see here are the ones that I currently have in my MongoDB database on MLab. Beautiful. So our video application is ready to be deployed to Heroku, and that's what we will do next. All right, now we're ready to deploy our front-end application. Just like the backend, first we need to add it to a Git repository. So here in the project folder, let's add a git ignore file and ignore the node modules folder. Save the changes. Now here in the terminal, let's run git init. This initializes a Git repository. Next, we need to stage our files. So git add period. And finally, we need to commit our files. So git commit -m with a message like initial commit. Good. So our application is in a Git repository. Next, we need to create a Heroku app. But before we do that, I want you to open up Google and search for Heroku build pack for create React app. Here, let's take a look at the first link. A build pack is essentially a collection of scripts that prepare an application to be deployed to Heroku. Heroku has a bunch of build packs for various environments like Ruby, Node, and so on. But at the time of recording this video, it doesn't have a build pack for applications generated with Create React App. That's why we need to grab this build pack from this GitHub page. Now, if you scroll down, here you can see how you can use this build pack when creating a Heroku app. So you run Heroku create, give your application a name, and then supply this switch, build pack. And here's the address of the Git repository for this build pack. So copy this. Now back in the terminal, in our vidly folder, let's run Heroku create -- build pack, and then paste the address of this Git repository. Beautiful. So now we have a new Heroku app. So the final step is to push our code from our local repository to this remote repository. So git push Heroku master. Okay, our application is deployed. So let's open it with Heroku open. And here's our video application in the cloud. All right, the first thing we're going to do is to reset up our development environment to make sure we're using the latest version of React. So open up your browser and head over to nodejs.org to download the latest version of Node. On my machine, I'm using Node version 12.14. Going forward, React no longer supports the global installation of the Create React App package, so you need to uninstall it and then bring it using a tool called npx. So first, let's uninstall the global installation of the Create React App. So we type sudo, that is if you're on a Mac, npm uninstall -g create react app. All right. Now we're going to bring this using a tool called npx. So npx is a new tool that came with Node version 5.2, and it's basically a Node package runner. So with npx, we can download and run the latest version of a package. For example, we can download the latest version of Create React App and run it right here. So we can create a new app called React-Advanced, all using one command. So previously we had to use npm to install the latest version of this package once in a while and then run it separately to create a new app. With npx, we can do all of this using a single command. And this package will no longer be stored globally. So we're not going to pollute the global space. Okay. So let's go ahead with this. This is going to take a little while, so I'm going to pause the recording. All right, now I have a new React app using the latest version of React. If you encountered any errors during this process, that means there's something wrong with your machine or your configuration. Unfortunately, that's not something I can help you with. You need to do your own research. So simply copy paste the error message you get in Google, and I promise there are other people who have encountered the same problem. You can also post your question or the error you get on forum.codewithmosh.com. The only thing I'm going to add here is for Mac users. Chances are you may get an error about Xcode. If that's the case, simply type xcode-select-install. That's probably going to solve your problem, but I'm not going to promise that. Again, you need to do your own research, okay? All right, now let's go to this new folder, React Advanced, and run npm start. So this is telling me that I already have another application running on port 3000, and it's asking if you want to run this new app on a different port. Let's select yes. All right, so here on port 3001, I'm going to have a new React app. There you go. So we're going to use this app throughout this section. We're not going to build a real functional application with fancy features because we already covered that during the past 12 hours. So in this section, we're only going to talk about the latest React features that you need to understand to build new applications. Components. Here's a real example. Imagine we have 3 components, and in all these components, we want to have some kind of tooltip behavior. So when we hover our mouse over this component, we should see a tooltip, and when we move away from it, the tooltip should disappear. Now, how are we going to implement this? Well, in this component, we need some kind of state, like a Boolean flag called show tooltip. Next, we should handle mouse events like mouse over and mouse out. In our event handlers, we need to change state. So we need to reset the value of our Boolean field, that is show tooltip. Also, somewhere in this component, we need to conditionally render our tooltip depending on the value of the show tooltip flag. Okay. Now, we have to repeat the same logic in these other components. And here's the problem. If there is a bug in our implementation, or if you want to change how our tooltips work, we have to change every single component we have implemented this logic in. We use higher order components to solve this problem. So let's imagine we have this component. This is a component that we want to add the tooltip functionality to. We create a new function and pass this component as an argument to this function. In this function, we're going to return a new component that wraps our original component. In this bigger component, we're going to implement all that common functionality, such as the functionality for showing a tooltip. As another example, imagine we have multiple components that are fetching data from the backend. Whenever we're fetching data, we want to show a loader icon. We can implement that common logic inside this wrapper component. And with this, we no longer have to repeat it across different components. That is the idea behind higher order components. Let me show you this in code. All right, here in our project, in the source folder, I'm going to add a new folder called HOC, short for higher order components. We're going to write all the code for this demo inside this folder. So let's add a new component called movie.jsx. Now here I've installed a very powerful plugin called React.js Code Snippets. Let me show you. So let's go to install extensions. Here's the component I was talking about. React.js Code Snippets. If you haven't installed this, definitely do it because it makes it a lot faster to develop React applications. So with this component installed, I can type RCC, as in short for React Class Component, and press Tab. There you go. We have a basic boilerplate for a React Class Component. Now in this movie component, we simply want to render movie. Now let's say we want to enhance this component and give it the tooltip functionality. We're going to implement that functionality somewhere else in a higher order component, not here. So in the same folder, I'm going to add a new file. Now look at the naming convention, with tooltip. So by convention, we prefix these components with the word with. So with tooltip.jsx. Now here we're going to create a function called with tooltip. This function should take an existing component as an argument. So component. Now, in this function, we should return a new component that wraps our original component. It's going to enhance it. So let's return. Now here's a question. How do we create a class component? We type class, let's say with tooltip, extends react.component, right? That is how we create a class component. So in our function, we are returning a new component. That component is called with tooltip. Now let's import React on the top. All right. Now, in this class component, we need a render method, right? Inside the render method, we should return some elements. Let's say we're going to have a div, and inside this div, we want to render the component that is passed here. So we add that like this. However, as you know, this code is not going to work because if you want to use this argument as a component to render, we should capitalize the first letter. So capital C and capital C. Now, let's export this function. Export default with tooltip. Save the changes. I've installed Prettier. That is why my code gets reformatted every time I save the changes. All right, now let's go to our app.js. To keep things clean, I'm going to remove all the markup here. Instead, we want to render a movie component. So movie, there you go. I've also installed the auto import plugin. I believe I explained it earlier in the course. So whenever I reference a component, this plugin automatically adds the import statement. Now, let's save the changes and go back to the browser. So here's our movie component. Currently, it doesn't have any tooltip functionality, but we're going to enhance it with our higher order component. The first step is to go to movie.jsx. And instead of exporting this movie class, we want to wrap this with our higher order component function. So here we should call with tooltip and pass the movie class as an argument. Okay. Now let's save the changes back in the browser. We still see the same result. However, if you look at the component structure in this document, you're going to see something different. So let's open Chrome Developer Tools. If you have installed React Dev Tools, you should see these two tabs here, Components and Profiler. In the Components tab, you can see the component hierarchy of this document. So on the top, we have the app component. Below that, we have with tooltip. That is our higher order component. And below that, we have our movie component. Now we're going to implement all the tooltip functionality inside this component. So here's our higher order component. In this component, we should have some state that would determine whether we should show a tooltip or not. So let's set state to a new object with a property called show tooltip, which we initially set to false. Now, over here in this div, we need to handle the mouse events such as mouse over and mouse out. So on mouse over, and on mouse out. Now let's quickly create a couple of event handlers. So mouse over, here we use a lambda expression. In the body of this lambda expression, we're going to call this .setState and set show tooltip to true. Now let's duplicate this line and rename this to mouse out. And here we want to set the show tooltip property to false. Next, we're going to hook this up. So here we call this .mouse over, and here we call this .mouse out. We're almost done. Now, finally, we need to pass this state as a prop to this wrapped component. So let's give it a new prop called show tooltip. And here we pass this .state .show tooltip. Okay, save the changes. Now let's go to our movie component. All we have to do here is to render the tooltip conditionally based on the value of our show tooltip prop. So let me wrap this in parentheses and break it up into multiple lines so we can see clearly. So here's where we render a movie. Now right below that, we can use an expression like this. This .props .show tooltip, and here's a markup for our tooltip, some tooltip. Now in the real application, we're going to decorate this with a bunch of classes to make it look fancy. But in this section, we don't want to worry about any of these distractions. We just want to focus on the advanced React concepts. So save the changes. Now back in the browser, let's test our implementation. So hover, there you go. Here's our tooltip. Now let's bring up Chrome Developer Tools one more time and go to the Components tab. So here's our higher order component. It has this state, show tooltip, and it's passing this as a prop to our movie component. You can see that over here. Now there is a tiny problem in our implementation. Let me show you. Here in the app component, let's give our movie component a new prop, like ID equals 1. Save the changes. Back in the browser, look at the movie component. We don't see the ID prop here. The reason this is happening is because we forgot to pass the props in our higher order component. So here in the with tooltip component, where we render our wrapped component, we should pass any existing props. Currently, we are only passing this new prop. So that's the reason why the ID prop is not passed. But that is a very simple fix. We use the spread operator to pass any props that we have passed from the outside. So save the changes. Now back in the browser. And here's the ID prop passed to our movie component. So to implement a higher order component, we create a new function that takes an existing component, and here we return a new component. In this implementation, I'm returning a class component, but we can also return a functional component. All we are doing here is implementing some logic, and we're sharing this logic across different components. Earlier in the course, I told you that functional components are stateless and class components are stateful. So if you want to store some state, or if you want to use lifecycle methods, we have to use classes. Well, that's no longer valid since React 16.8. In React 16.8, we got a new feature called hooks that allow us to build functional components with all the features we have in class components. So we can use state and lifecycle features of class components. Now you might be wondering why this feature was introduced. Well, there are a few reasons for this. One reason is that classes are a bit difficult for some people to understand, especially new programmers. If you have a good background in object-oriented programming, classes are second nature for you. But that is not true for every programmer out there. Also, JavaScript classes are not like real classes that we have in object-oriented languages like C# or Java. They're essentially syntactic sugar over constructor functions. I talked about this in the second part of my JavaScript course called Object-Oriented Programming in JavaScript. So that's one issue. The other issue is that this keyword is confusing in JavaScript, and we have to deal with it all the time when we're building class components. And the third issue is that writing class components requires a bit of boilerplate code. We have to create a class that extends React component, Perhaps we have to create a constructor and so on. So that is the reason why the React team decided to spend some time and improve functional components. Now with the addition of hooks, we can create powerful functional components that have all the features that we have in class components. And our code looks shorter and cleaner. Let me show you. So here we have a basic counter component. Now I'm going to show you two implementations, one using a class component and the other using a functional component. Here's the implementation using a class component. So we have this class that extends the component class in React. Here we have the state. We have this event handler where we increase the state. As you can see, we have two references to the this keyword in JavaScript. And here's our render method. We're returning a fragment that contains a div for displaying the count value and a button for increasing the count. Now let's look at the implementation using a functional component. You can immediately see the code is shorter and cleaner. So this is the beauty of functional components. We don't have to create a class. We don't have to type extends component. We don't have to create constructors and call super to pass the props. We don't have any references to this keyword here. That is why I love functional components. Now look at line 4. Here we're calling the use state function. This is one of the hooks in React. It allows us to hook into React state. We didn't have this feature before React 16.8. So over the next few videos, we're going to look at hooks in more detail. In this video, I'm going to show you how to create a functional component with some state. So in the source folder, let's add a new folder called hooks. Here we add a new component called counter.jsx. Now, to create a functional component, we can type rsf and press tab and then escape. So nothing magical here. We have the import statement on the top and a function that returns a div. Now, over here, let's add a label counter. Now, this is where we want to display the value of our counter. So we need state, and this is where we use React hooks. So a hook is a function that allows us to hook into React features like working with state or lifecycle methods. So on the top, we're going to import a hook from the React library. It's called use state. So all these functions that start with use are examples of hooks in React. Okay. So here we're going to call use state. We give our counter an initial value like 0. Now this is going to return an array with 2 elements. So let's store it over here. Now the first element in this array is the value of our counter. That is equivalent to this.state.count in a class component. So we can store it in a constant called count and then display it over here. Pretty straightforward, right? Now, in class components, we also have a method called this.setState that we inherit from the base component class in React. But here we don't have inheritance. That's why we don't have the setState method inside the function component. So how are we going to update the value of our counter? Well, I told you that the useState function returns an array with 2 items. The first item is the value of our counter. The second item is a function for updating this value. So that is equivalent to this.setState. Let's store it in a constant called setState. So this is a function, okay? Now, we can rewrite these 2 lines using array destructuring. So instead of declaring 2 separate constants, we can extract these items, the first and second items, straight away on line 4. So we use the array destructuring syntax. We type square brackets, and then we type count and set state. So with this syntax, the first item of the array that is returned from this function will be assigned to count, and the second item will be assigned to set state. Okay. Now we don't need these 2 lines. Our code is cleaner. So let's add a button for increasing the count value. So button called increase. Here we need to handle the onClick event. Now here we pass a lambda expression, and in the body of this lambda, we're going to call this function to update the value of our counter. So set state. Now, what is the new value? That is the existing value plus 1. Okay? So this is how we can use hooks in a functional component. Very simple. Now we have a compilation error because we are returning 2 elements. So let's wrap these inside a fragment. We're almost done. Now we should add this component to our app component. So let's go to app.js and render a counter component. So here's our counter. Increase. There you go. Now we have a stateful functional component. We can also declare multiple state variables. For example, let's add an input here, input of type text. Here we need to handle the onChange event. We pass a lambda expression that gets the event. Now we should use e.target.value to update a state variable. So first we need to call useState one more time. We give our state variable an initial value, in this case, an empty string. Now we get the result and destructure it. Let's call this variable name and the function to update it, set name. So look at the naming convention, okay? Now, over here, whenever the value of this input field changes, we should call the setName function and pass e.target.value. So we call setName and pass this value. Now let's change our label to include the name of the person and say this person has clicked count times. Save the changes. Now, here in the browser, I type my name, Mosh. Our label gets immediately updated. Mosh has clicked 4 times. So this is how we can declare multiple state variables. The values that we're passing here are just the initial values for those variables. In this case, I'm passing an integer. Here I'm passing an empty string. We can also pass an object. There are no limitations. There is just one rule you have to follow. You cannot call hooks inside loops, conditions, or nested functions. For example, we cannot call this hook inside an if statement or a loop. If we do this, we're going to get an error. Let me show you. So I'm going to type if count equals 0. Then we're going to call this hook. Save the changes. Look at this error. React hook useState is called conditionally. React hooks must be called in the exact same order in every component render. What is this and why does it matter? Well, we're calling this hook multiple times in this function. Every time we're supplying a different value. So here we're passing an integer, and this integer is assigned to this variable. The second time we're passing a string, and this string is assigned to this variable. Now React is going to store this state somewhere internally that we don't see. That is how these values are not wiped out between component renders, because every time this component gets re-rendered, this function gets called again, so these variables have to be re-initialized. So React is going to store these values somewhere internally. We don't see it and we don't care about it. Now, how does React know that this value belongs to this variable? In other words, if React has some kind of storage, how does it know what value belongs to what variable? Well, React relies on the order in which hooks are called. So the first time we call this hook, React creates a state variable and stores it somewhere. Let's say in an array. The second time we call useState, React is going to create a second state variable. This is the reason why we cannot use hooks inside if statements or loops, because these will mess up with the order of calls to hook functions. In other words, with this structure in the first render, both these hooks are going to get called because count is 0. Now, if we click on this button, the value of the count is going to be increased. So in the second render, this hook is not going to get called. And this will mess up with how React manages the state of this function. So we cannot call hooks inside loops, conditions, or nested functions. As I was reviewing this video, I realized I made a tiny mistake. So when using the state hook, I ended up calling this function setState. This is a very generic name that you should avoid. The name of your setter function should match the name of your state variable. So the name of our state variable is count, and it's better to call this function setCount, because this function is purely responsible for setting this particular state variable. In class components, we have lifecycle methods like component.didMount, component.didUpdate, and component.willOnMount. If you have been developing applications in React for a while, you've probably noticed a problem when using these methods. Our logic gets spread all over the place. Some parts of the logic end up in component.didMount, other parts end up in component.didUpdate, and some other parts end up in component.willOnMount. We have to go back and forth between these lifecycle methods to see what is going on. That is the problem with these lifecycle methods in class components. In function components, we have a single hook called useEffect that does the job of all these three methods. So it takes a function, and this is where we implement all the logic in a single place. Let's see this in code. So here's our counter component. Let's say when this component gets mounted, or every time it gets updated, we want to set the title of this document to this message over here. So in our counter component, we're going to use the effect hook. This function allows us to hook into our component's lifecycle methods. So in class components, we have component.didMount. This method gets called the first time a component gets mounted. We also have component.didUpdate. This method gets called whenever our component gets updated. This happens when a component receives new props or its state changes. Now, in functional components, we use the effect hook. So here we pass a function. I'm going to pass a lambda expression. And this function that we pass over here, gets called every time our component renders. So that applies to both the first render and any subsequent renders. So with this implementation, all our logic will end up in a single place. It's not going to be spread over two different places. Okay? So here, let's set document the title. We can use a template string. So I'm using the backtick character. So we can dynamically insert values. First, we add the name variable. And then we type name has clicked, count times. So name and count are arguments in this template string. Okay. Let's save the changes. Now, so here's the initial title of our document. Now, every time I increase the count, it gets updated. Also, every time I change the name here, the title of our document gets updated. Now here we can supply a second argument to this function. That is an array of dependencies. So as I told you, this function gets called every time our component renders. So that applies to the first render and anytime it receives new props or its state changes. Now, there are times you don't want this function to be called every time a component re-renders, perhaps for performance reasons. So this is where we use this array of dependencies. In this array, we list all the state variables that our effect hook is dependent upon. For example, if we add count, that means this function gets called only when the value of the count variable changes. So if we change the name, the title of the document is not going to get updated. Let me show you. So save the changes. So initially the count is 0. If we increase it, we see it updated over here. But if we set the name, the title of the document does not get updated. Because this effect hook is not dependent on the name variable. It's only dependent on the count variable. Now in situations like this, you see a warning in the console. React hook useEffect has a missing dependency, in this case name. Either include it or remove the dependency array. So basically this warning is telling us that we should include the name here. The warning thinks we have forgotten to include this variable here. So it's telling us that we should include it or completely remove this array. So this function gets called every time our component renders. Okay. Now, one last thing. In class components, we have another lifecycle method that is component will onMount. This is where we write cleanup code. For example, clearing our timers, disconnecting from the server, and so on. When using the effect hook, here we can optionally return a function. And in this function, we can write all that cleanup code. So any code that we previously wrote in component will onMount would end up here. Now with this implementation, you can see
all the logic around a certain feature will end up in a single place. It's not spread over different lifecycle methods. So let me quickly demonstrate this. Console.log cleanup. Now, whenever we increase the count or change the name, we see a cleanup message. This is because this function has no dependency, so it's getting called every time our component gets re-rendered. And as part of this, React first calls our cleanup function. Now, there are situations where this could have a performance penalty. For example, you don't want to disconnect a network connection every time the user types something in a text box. In those situations, you can pass the dependency array to prevent this from happening. So you learn that using the effect hook, we can encapsulate all the logic around a certain piece of functionality in a single place. And this gives us an extra benefit. We can extract this logic, put it in a separate module, and reuse it across different components. So in this demo, let's imagine somewhere else in our application, we need to have this behavior, be able to set the title of our document. So in the hooks folder, let's add a new file. Look at the naming convention, use document title. So I'm prefixing this custom hook with use to be consistent with the hooks in React. Okay. So that's a JavaScript file. Now, in this file, we're going to create a function called use document title. Now let's go back to our counter component and move this code over here. So we have the call to the use effect function, and that means we need to import it on the top. So import use effect from React. Now, to make this more reusable, instead of hard coding this message over here, we want to give this function a parameter called title and then set it over here. Now, technically, we don't need any cleanup code for setting the title of a document. This was purely for demonstration, but I'm going to leave it here in case you want to look at this source code later on. Also, make sure to remove this empty array of dependency, because otherwise this hook is not going to get called after our component got mounted. So if you update the name or count variables, our hook is not going to get called, okay? So delete. Now finally, we need to export this as a default function. Save the changes. Now we have a reusable piece of functionality. We can go to our counter component, and as you can see, we no longer have to import the use effect function. So let's delete it. Instead, we should import use document title from this module. And then we can call it over here. So our component code is cleaner, it's simpler, and we are reusing this logic. So if this logic has a problem, or if you want to change its behavior, there is a single place where we need to make the necessary changes. This is another benefit of using hooks. We can extract common logic into custom hooks and share it across different components. Just one last thing. I realized that I forgot to pass the title to our custom hook. So this is where we should pass name has clicked count times. So this is how we can use a custom hook. You have learned a lot about hooks. Now let's bring everything you have learned together and build a real component, like the kind of component you see in a real application. So for this demo, we're going to consume this REST API. You probably know about this, JSON placeholder.typicode.com. This is a fake REST API. It has various endpoints for getting a list of posts, comments, and so on. For this demo, we're going to consume the list of users. So this returns an array of user objects. Every user object has these properties. So in the hooks folder, let's add a new file, users.jsx. We're going to generate a functional component. Beautiful. Now, in this component, we should make an API call to JSON placeholder. For that, I'm going to use Axios. So let's open up the terminal and install Axios. All right, Axios is installed successfully. Beautiful. Now, let's import it on the top. Import Axios from Axios. Now, in the class component, we should make an API call in the component.mount method. That is when our component is mounted in the DOM. In functional components, we don't have that method. Instead, we use the effect hook. So here we call use effect and pass a function. Inside this function, we're going to call Axios and pass the address of our API endpoint. So I'm going to bring that from our browser. There you go. Now, this returns a promise. I prefer to await it. I don't want to call the then method. That's really ugly. So we await this promise and get the result. Now, result.data returns the array of user objects that we get from the server. We should store this array in the state of this component. So here we need to use the state hook, use state. We give our array of users an initial value, in this case, an empty array. As you know, this returns an array with 2 items. So let's destructure it over here. The first item is our state variable. Let's call it users. And the second item is a function to update this state variable. Set users. Now, over here, we're going to call set users and give it result.data. Now, there is a tiny problem here. Because we have used await here, we have to decorate this function with async, but React does not allow this. So the function that we pass to the effect hook has to be a regular function. To solve this problem, we can encapsulate these 2 lines inside an async function. So async function, let's call it get users. Now we move these 2 lines over here. So inside this callback function, we are defining another function, okay? But this function is not going to get called automatically. We have to explicitly call it. So get users. Now, I'm not going to await this because if I do this, then I have to decorate this function with the async keyword. We don't want to do this. So we simply call it. Now, at some point, the promise that is returned from the access function is going to get resolved. So the control will move here. The set users function will set our state variable. This will cause our component to re-render. So let's render the list of users over here. We add an unordered list. Here we're going to map users. We map each user to a list item. Now inside this list item, we're going to render user.name. And also, we should assign a key to this list item. We're going to use user.id. Save the changes. Now let's go to our app component and render our users component. Let's test our application. So localhost port 3001, and here's the list of users retrieved from the server. So let's say we have a component tree like this. On the top, we have an object that represents the current user. Let's say in this component over here, we want to access the current user. To do this, we have to pass this object as a prop through this middle component so we can access it here. This is what we call prop drilling. Because at every level, we have to drill a hole to pass a prop. Over time, as our application grows, as we have more components and more data to share, this approach becomes unmaintainable. A few years ago, before we had context, a library called Redux came to solve this problem. Now, Redux brings some additional features, but it was originally designed to solve this particular problem. So with Redux, we don't have to drill properties at every level. Instead, we have a concept called store, which is an object that stores the global state of our application. That is the data we want to share across different components. So in this component, we can store the current user in the store, and we can pull it out in this component over here. Basically, any component can get data from the store. That is the idea behind Redux. Now, Redux really requires its own course, and that's something I'm planning to do in the near future. But if you have some experience with Redux, you probably know that Redux brings a lot of complexity. So a few years later, React team introduced a new concept in React, context. With context, we can pass data down our component tree without prop drilling. So in this component, we're going to provide some context or some shared data. And in this component, we're going to consume that context. So when using this feature, we deal with providers and consumers. Over the next couple of videos, I'm going to show you how to work with providers and consumers. First, we're going to look at using context in class components, and then we're going to look at the implementation in functional components. In this video, I'm going to show you how to use the context API in class components. So in the source folder, let's add a new folder called context. Now in this folder, let's add a couple of components to represent a hierarchy. So the first one is going to be movie page.jsx, and the second is going to be movie list.jsx. So on the movie page, we're going to have a movie list. Now let's implement these components. So over here, we type RCC tab. Now we have a class component called movie list. Here, let's just render movie list. Save the changes. Beautiful. Now on the movie page, first, let's implement this as a class component. Now here we're going to render a movie list. So movie list. Pretty straightforward. Now in our app component, we want to render a movie page component. So let's go to app.js. Now the new create React app package generates this as a functional component. So for this demo, let's delete everything in this file and generate a new app component using a class. So delete RCC tab. There you go. Finally, we render a movie page here. Good. Save the changes. So here's our component tree. We have the app component on the top, then movie page and movie list. Let's say the app component stores the current user, and we want to access it inside this component. Perhaps based on the current user, we want to render some content dynamically. For example, if the user is logged in, we want to display an edit link. Otherwise, we want to hide it. So here in the app component, let's define some state. We set it to an object with a property called current user, which is an object itself. And here we have a property called name set to, let's say, Mosh. Save the changes. Now to pass this object down our component tree, we need to create a context object. So in our context folder, we add a new file called user context.js. In a real application, we can have different types of contexts. So we use the user context to share the current user. We could also have a theme context for sharing the current theme and so on. Now, in this file, first we need to import React. Next, we call React.createContext. This returns a context object. Now, by convention, we should name this object using the Pascal naming convention, the same convention we use to name our components. So let's call that user context. So we capitalize the first letter of every word. Okay. Now finally, we should export this. So export default user context. Good. So the first step is to create a context object. We have done that. The second step is to provide this in the top component. In this case, we're going to go to our app component and provide our user context. So first we need to import it. Import user context from the context folder /user context. Now we're going to wrap this element inside a provider component. So we type user context dot. Look, this object has three properties: consumer, provider, and display name. We're going to look at each of these individually. So first, let's use the provider. This returns a provider component. So we're wrapping these elements inside a provider component. Now, this provider component is nothing magical. It's just like a regular React component. It has a special prop called value. And this is where we're going to pass an object down our component tree. In this case, we're going to pass this object. So we type this .state.current user. Okay. Save the changes. The third step is to consume this context somewhere in our component tree. We can go to any component. In this case, we're going to go to our movie list and consume the user context. First, we need to import it on the top. So import user context from the user context module. Now, we have to wrap this element inside a consumer component, just like how we wrapped the content of the app component inside a provider component. So we type user context dot consumer like this. Now here's the tricky part. This component expects a function as a child. So we cannot pass this div over here. Otherwise, we're going to get a runtime error. Let me show you. So this is the error I was talking about. Render is not a function. This happened because we passed this element directly as a child of this component. But this component expects a function. So here we should pass a lambda expression. So we add an expression. This function should have a parameter. We could call it anything. We can call it value, or we can call it user context. This goes to, and this is where we're going to return our div element. So the consumer component expects a function as its child. Okay. Now save the changes. Back in the browser. We don't have any errors. Look at our component tree. On the top, we have the app component. Below that, we have context.provider. This is a generic name that is automatically generated. But as we create different types of contexts, it's a good practice to give each context an explicit name. So we go to our user context file. And after we create this context object, we set user context.display name to a specific name, like user context. Now, back in the browser, instead of context.provider, we have user context.provider. So this is a good practice that you need to follow. Now, below this, we have our movie page component, movie list component, and here we have a consumer. Now, this consumer has a context object, which is an object with a property called name set to mosh. This is our current user. So we can get the name of the current user and render it on the movie list. Let me show you. So we go to our movie list component. This user context object that we have over here is exactly this context object that you see here. So after movie list, we can render user context dot name. You could also rename this to current user, whatever you prefer. Now save the changes. And here's the name of the current user. Beautiful. So this is how we use the context API. First, we create a context object, then we provide it, and finally we consume it. Very easy. Now, what if you want to consume this context outside of the render method? Let's say in one of the lifecycle hooks like component did mount. In that method, we don't have access to this consumer component. So how are we going to work with this user context object? That is pretty easy. First, after creating this class, we need to set one of its static properties. So we type movie list dot context type. This is what I mean by a static property, a property that belongs to a class, not an object. Okay. So we set the context type property to user context. That is the user context that we imported on the top. Nothing magical. Now let's implement the component did mount method. Over here, we can log the context using this context. So this property returns our current user object. Take a look. So here in the console tab, we have this object that represents the current user. Now, in a real application, we can make decisions in this component based on the current user. One last thing before we finish this video. There is another way to set the context type property. Instead of setting it after creating the class, we can set it as part of creating the class. So let's delete this line. We go over here. Inside this class, we type static context type, and then we set it to user context. So this static keyword is saying that we're setting a static property on this class. Some people prefer the second approach. Other people prefer to set it explicitly after creating the class component. So this is how we use the context API in class components. Next, I'm going to show you how to use the context API in functional components. In this video, I'm going to show you how to use the context API in functional components. As you will see at the end of this video, using the context API in functional components is a lot easier than class components. You're going to love it. So we're going to extend this hierarchy and introduce a new child component called movie row. So the movie list component can contain one or more movie row components. So in the context folder, let's add a new file called movie row.jsx. Now to generate a functional component, we type RSF, that is short for React Stateless Function. Tab, there you go. Now to use the user context inside this component, first we need to import it on the top. So user context from user context. Now we have a special hook called use context. So we need to pull that out from the React module, use context. This hook only works with functional components. Now, in this function, first we're going to call use context and pass the user context as an argument. This returns our user context object, which is the current user. So we can store that over here, current user. Now, in this function, we can do anything we want with this object. We can log in on the console, that is context, or we can render the name of the current user. So current user dot name. Save the changes. Now let's go to our movie list component and add a movie row component. So here's the function that is the child of this consumer component. Inside this div, after displaying the name of the current user, I want to add a movie row component. Save the changes. So this is what we're returning. We have a div, some text, and the movie row component. Now, back in the browser. So here's our movie row component. One immediate advantage that we have here is that we don't have a consumer component under the movie row component. In contrast, in our movie list component, because we use the consumer component, now we have an extra child here. And over time, this makes our hierarchy more convoluted. So if you use functional components, you're not going to see these consumer components in your component tree, okay? So here's our movie row component. You can clearly see the name of the current user. Also, we have the current user displayed in the console. Now let's compare these two implementations. Here's our movie list component. To use the context API here, we had to set this static property. Then we had to add this consumer component, which made our component tree a bit convoluted. And even worse, we had to use this function over here. This function is distracting us from seeing the actual content of this method. It's introducing some extra complexity. Now compare this approach with our functional component. All we had to do here was to call this hook, use context. So going forward, prefer functional components to class components. So you have learned how to consume a context object in your component tree. But what if you want to update the context? That's what I'm going to show you in this video. So in this little app that we have built, we are assuming that the user is initially logged in. We're going to change this behavior and simulate the scenario where the user is not logged in. Then we're going to build a login component with a button. When we press the button, the user should log in, and then we should see the user's name over here. Now, before we get started, I want to clean up this UI a little bit. So here's our movie list component, and here's our movie row component. I want to add a label here like movie row for clarity. So let's go to the movie row component and add this label, movie row. Save the changes. Now we have a consistent UI. Okay, beautiful. So how can we update the context? Well, look at our app component. In this user context, we're providing this object, which is part of the state of the app component. Now I got a question for you. Forget about the context for a second. How can we update the state of a component higher in the component tree? We talked about this earlier in the course. So because we have the state here, we should also provide methods for updating the state here, and then pass those methods as props to our child components. So over here, I'm going to add a method called handle logged in. Let's say we get a username. This is the value that the user enters on the login form. So we get the username. Now we should call the server and get information about this user. I'm going to simulate that using a console.log statement. So getting the user with this username. Okay. Now let's imagine we get a user object from the server with the name set to Mosh. Now we should call this.setState. We're going to set the current user property to the user object that we get from the server. Okay. Now we have a method for updating the state. We should pass this method just like the current user using our context object. So we're going to change the structure of the object that we're passing down. Instead of passing down the current user, I'm going to pass an object with two properties. One of them is current user, which we set to this.state.current user. The other is a property called onLoggedIn, which we set to this.handle logged in. Let's save the changes. So take a look. This is the object that we're passing down in our component tree using our context. Now we should modify our child components because we have changed the structure of the object that we're passing down. So let's go to movie list. Our user context no longer has a property called name. It has a property called current user. Now current user may be null, so we need to check for it. So let's write an expression like this. User context dot current user. If this is truthy, then we're going to read user context dot current user dot name. Otherwise, we're going to return an empty string. Save the changes. Now we should make the same change in the movie row component. So movie row. Now here I've called this object current user. Let's rename this to user context. Otherwise, we'll end up with current user.current-user.name. So rename user context. One more time. If user context that current user is truthy, we're going to read user context that current user.name. Otherwise, we're going to get an empty string. Save the changes. So our application is still working. We haven't implemented the concept of updating the context. We have simply changed the structure of the context object. Okay. Now to update the context, let's add a new component called login. So login.jsx. Let's use a functional component here. So RSF tab, beautiful. Now let's add a button with a label like login. We should handle the onClick event here. Now, what should we call here? We should call the handle logged in method that we passed down from our app component. So in app component, this is the object that we're passing down using the context. So back in the login component, let's import the useContext hook. Now, we call useContext. What kind of context do we want to use here? User context. So we get the result and store it over here. Now, here we should pass a Lambda expression. So whenever this button is clicked, we're going to call user context that onLogged in. And in this form, we know the username of this user. So whatever that is, we're going to pass that here. When the user clicks on this button, the handle logged in method in the app component gets executed. This is where we get the user information from the server and then update the state. Now, the moment the state gets updated, this value prop will also be updated because here we're using this.state.current user, right? So this provider is going to provide a new context object to our component tree. Now, all consumers will be notified and they will refresh themselves. We're almost done. Now, we should set the current user to null and also add the login component over here. So login, there you go. Save the changes. Let's test our application. So initially we're not logged in. That's why we don't see my name over here. Now let's click on the login button. There you go. So this verifies that we successfully updated the context object. So to recap, to update the context, we added this method in our app component. This is the method that is responsible for updating the state. And then we pass this method down using our context object. With this, any component in our component tree can call this method, just like how they can access the current user. As your application grows, you may want to create different types of contexts. For example, in this application, let's add a shopping cart context. The concept of a shopping cart is different from the concept of the current user. So it's not something we want to add to the existing user context. So in the context folder, let's add a new file called cart context.js. Now to save time, I'm going to go and copy some code from our user context, paste it here. Now we need to rename user context to cart context, and here as well. Okay, now we need to provide this context in our app component or any component that wants to share a shopping cart object to its child components. So let's go to app.js. On the top, first we should import cart context from context/cart context. Now, in our render method, just like how we provided our user context, we're going to provide a shopping cart context. So we type cart context.provider. We're going to wrap everything inside this element. So we're providing two different contexts. Now, for this context, what value should we set? Well, let's set this to an object with a property called cart, which is set to an array. Well, save the changes. With this, we can go to any child component and consume this context object. So let's go to our movie row. That is our functional component. This is how we're consuming a context in a functional component, right? So let's duplicate this line. This time, we're going to consume the cart context. So let's get that. And now we can display it on the console. So console.log cart context is cart context. Let's verify this. So over here, let's look at the console, and here's our cart context where we have an empty shopping cart.